Hey pre-calc, these are your 1.6b notes for modeling with equations. Would you please make sure that you write down everything you see on the paper today so that you get all of this copied down in your notes? So for the first problem, we're going to do a mixture and concentrations problem like the ones we've been doing in class. So this will sound pretty familiar. To start with, we have some sort of soft drink like an orange soda that's considered to be naturally flavored, and naturally flavored is in quotation marks because it only contains 5% orange juice. So there's some new regulations out, and they say that in order to have this like natural as part of like for the company to be able to claim that it's naturally flavored, that it has to be at least 10% juice. So instead of 5%, we're up to 10%. And so what the manufacturer needs to know is how much pure juice, pure orange juice, must be added to 900 gallons of orange soda to meet the new regulation. Okay. So on problems like this with mixtures and concentrations, I'm a big fan of drawing pictures. And actually, I think if you guys kind of latch onto this, it'll help you figure these problems out. So to start with, we have 900 gallons. So I'm just going to draw a silly picture of 900 gallons of this orange soda. And you can just sort of shorthand that out. And so of this 900 gallons right now in the tank, not quite full, we'll say, 5% of this is actual orange juice. So I'm kind of curious about how much orange juice that is. So I'm going to take 5% or 0.05 times 900. And that's going to tell me how much orange juice is sitting in this container. Well, let's see, 0.05 times 900. 5 times 900 is 45, right? 5 times 9 is 45. And those two decimal places are going to cancel out those two zeros. So you're going to get 45 gallons of orange juice. Obviously, if you didn't want to do that in your head, you could use a calculator. If you heard me tapping away, I used my calculator first, and then I was like, oh yeah, that makes sense. It should be 45. So then we're going to add X gallons of pure orange juice. So this is going to be 45 plus X. And we're going to add up to my thing of orange soda here. It's going to have its original 5% of orange juice because we didn't take that out this time. And on top of it, we're adding in X gallons of orange juice. So when we get to the end of this, we want to have 10%, that's our new goal, of 900 plus however much we added. We want that to be our total amount of juice. So this is going to be 0.1 times 900 plus X. Because now we have 900 of the original gallons, but we've also had the X gallons that we've added in. So when I go to solve this, I have 45 plus X equals, let's see, 10% of 900 is 90. And then plus 0.1X. I'm going to take 45 away from both sides. So I have X equals 45 plus 0.1X. That's if I subtracted 45 from both sides. Okay. Then I'm going to subtract 0.1X from both sides. When I do that, this is 1x, and 1 minus 0.1 is 0.9x. So that equals 45. And then I'm going to divide both sides by 0.9. And I get, well, let's see, 45 divided by 9 is going to be 5. But there's that point there, so I think it's probably going to be 50. I'll double check that on my calculator. Yep, sure enough, 45 divided by 0.9 is 50. And this is gallons of pure orange juice. So, mixture problems, draw pictures please. Make sure you're thinking about what you're adding together and what you're multiplying. In this case, we had orange juice plus some unknown quantity of orange juice was equaling our ending amount of orange juice. So make sure that you're adding like units. And then it's always a good idea at the end to double check and make sure that this makes sense. So if I were to plug this back in, I would have 950 gallons total. And if I find 10% of that, so 0.1 times 950, well, that should be 95, right? 95 is representing the gallons of OJ total, right? Well, I started with 45, I added 50, and 45 plus 50 really does add up to 95, so that does make sense to me. It does sort of check. All right, the next problem that we're going to look at is a distance, rate, and time problem, kind of like the one that you guys did today in class, or maybe the two that we did today in class. For problems like this, there's sort of another trick. Pictures usually help, but there's actually something even better than pictures that work for distance, rate, and time, and I'll show you that in just a second. So this problem, we have a jet going from New York to LA, and they give us the distance as 4,200 kilometers. They tell us the speed for the return trip was 100 kilometers per hour faster than the outbound trip. And then they say that if the total trip took 13 hours, what's the jet speed from New York to LA? So here's my trick that makes solving these distance, rate, and time problems pretty quick and snappy. On the top, we're going to make a table to organize this information. And on the top of this table, I want distance, rate, and time. Okay. And then on the side of the table, you're going to break down whatever the two parts, because these always have two parts. There's always like two trips. So for us, this is going to be from New York to LA, and then from LA back to New York. Okay. And then we might have some totals that we're going to have to think about. So when I make this table, it's always distance, rate, and time, and then there's always going to be two things, or maybe three, that we're separating out the information from. And so in this case, it's the trips. So the distance for both of the trips is the same, 4,200. So I fill that in. The rate, well, let's see. I think that's my x. So it says, what was the jet speed from New York to LA? So that's my x. I don't know what it is. The time, well, I know the total trip time took 13 hours. So I'm going to put that in my time. And then let's see, is there any other information that I can get? Well, the speed of the return trip, so that's coming back from LA, is 100 miles an hour faster than the trip there. So this is going to be x plus 100 because it's 100 miles faster. Now we've taken all the information we can out of the paragraph or the given information, and we put it into our table. And now we're going to use the table to set things up. And in addition to the table, so I like to call this the dirty table because it's DRT. So it's dirty. This is the dirty table, and I'm going to set up the dirty triangle, which if you've taken physics, some of you might recognize. The dirty triangle is a triangle that tells you the relationship between distance, rate, and time. And the trick with this triangle is that whatever you want, you cover that up. So for instance, if I wanted to know what distance is equal to, I cover distance up with my finger and I say distance is rate times time. If I wanted to know what time was equal to, I would cover time up with my finger, and since it's distance over rate, because the distance is on top, I would know time is equal to distance divided by rate. And then lastly, if I wanted to know what the rate is, I cover it up and it's distance divided by time. So this is just a shortcut. This dirty triangle is a shortcut for setting up your relationships between distance, rate, and time without really having to think about it too much. And it's dirty because it's DRT, dirty. Okay, so what I have here is total time, but I don't know the periods of time for New York to LA or LA to New York. So I'm going to use the dirty triangle. What I want is time, and I see that time is equal to distance over rate. So in this part, I'm going to put the distance over the rate and the distance over the rate. Okay. And now, because I know that the time from one part of my trip plus the time from the other part of my trip is going to equal total time, this is going to set up my equation because I'm going to have 4,200 over x. That's the time it took for New York to LA, plus the time it takes to come back, LA to New York, equals my total time. Okay, so this is a way to take some really abstract quantities. You set everything up in your dirty table, and then it gives you kind of the equation. It spits it out for you. Now, once we get here, we're going to probably want to clear the denominators by using the least common denominator. So I'm going to multiply by x and x plus 100 on both sides. When I do this and I distribute, here an x on top and an x on bottom are going to cancel out. So I'm going to have 4,200 just times the x plus 100. And then when I distribute this into this parenthesis, the x plus 100s are going to cancel. And that's just going to leave me 4,200 times x. On this side, nothing cancels, so I get 13x times x plus 100. And from here, it's just a matter of solving. So I'm going to distribute. I get 4,200x plus 4,200, let's see, within 2 more zeros added on. So 420,000 when I distribute, plus 4,200x. On this side, 13x times x gives me 13x squared, and 13x times 100 gives me 1,300x. Okay. I see that I have a quadratic, and so that tells me I need to get 0 on one side. Since it's a positive 13x squared, I'm going to move everything over to the right-hand side. So, I guess I can combine like terms here also. So if I combine my like terms, the 4,200x and 4,200x give me 8,400x plus 420,000. And then let's see, I'm going to take 8,400x away from both sides. When I do that, I get 420,000 equals 13x squared, 1,300 minus 8,400. Gives me negative 7,100. And then I'm going to take 420,000 away from both sides. Okay. And since we're to a place where we have a quadratic set up, I'm going to go ahead and ask you guys to solve this using the quadratic formula on your own. So for your notes tonight, please solve this using the quadratic formula. If you forgot the quadratic formula, you can open up the front cover of your textbook, and right in the very front cover, right in the middle of the page, is the quadratic formula just sitting and waiting for you. But try to do it from memory if you can, and then see if you've got the formula set up right. And we will check our answers to this problem tomorrow in class. All right, that's it for notes. Thanks, guys.